guys, Mr. Gucci here to help you with your 6.2 ionic compounds homework. Here we go. All right, so you have these tables here that you are going to fill out, and I am either going to give you the name of the ionic compound, I'm going to give you the ions in that compound, or I'm going to give you the formula of that ionic compound, and you have to figure out the other two spaces. Okay, so that's how this is going to work. Let's get started with which I think is the most simple one, which is let's start with giving you the ions, and you need to give me the name, and you need to give me the formula unit. Okay, now, in order to do this homework, I have a few things open right now. First of all, I have a list of all the uh, monoatomic ions and their charges, just in case I need that or I forget it. Okay, this is very useful for me. This was attached to the homework. Also attached to the homework, everyone got a link to their own copy of this ionic compound workspace, where you could combine ions together to see how they would combine to form a compound. All right, so use this as a workspace. If you feel you need it, that's open to you. Okay, and there's enough slides here that you can do multiple different ones at once. You can always copy a slide or delete a slide if you need it. All right, let's get to it. So first things first, we have a compound with CO3 plus and chloride. So let's start with the easy thing, the name. All right, so CO is cobalt and Cl minus is chloride. Okay, but we are reminded, does this name have a Roman numeral? Well, here's what I can do. Is cobalt listed here as an ion that has a definitive charge? I do not see it. I do not see cobalt here at all, which means it's one of those ions that can have multiple charges. So this is cobalt with a 3 plus charge. I'm going to make this cobalt 3 chloride. Okay, very good. That's the name of this compound I'm going to make. Now I need to figure out the ionic compound formula unit. Now, there are many different ways to do this. I'm going to start with using this ionic compound workspace here. Okay, so we're making an ionic compound from plus 3 cobalts and minus 1 chloride. So here I go, plus 3 cobalt, and I'm going to combine 1 chloride. That's not enough. 2 chlorides. That's not enough. 3 chlorides. Very good. Remember, you stop when you have a perfect little rectangular square. Okay, so what I see here is that I needed 1 cobalt, and I needed 3 chlorides. Okay, so the formula for this thing is going to be CO1 Cl3. All right, I got to make this a little subscript though. Okay, that little 3 there has to be made into a subscript. So format text subscript. Okay, this is it. This is the formula for cobalt 3 chloride. Remember, this is cobalt 3 because the cobalt has a plus 3 charge. Most common mistake, people think, oh, cobalt 3, that means there's 3 cobalts in this. No, that Roman numeral, remember, is the charge. Okay, let's do the next one here, okay? Calcium and oxide. So here we go. Calcium, all right, and then that O2 minus is oxide. All right, now, do I need a Roman numeral here? Well, let me take a look at this monoatomic ionic charges sheet. Calcium. Hey, here's calcium. Look, calcium is always going to be plus 2. So no, I do not need to do a Roman numeral here, okay? I don't need a Roman numeral, all right? It's just calcium oxide, all right? Now, what is the formula, okay? What is the formula? Well, calcium is 2 plus, oxide is 2 minus. So you might think, oh, that's easy. I'm just going to use one of each. Let's just double check and take a look. All right, here we go. I'm just going to distribute these things back. Okay, cool. So calcium is 2 plus, oxide is 2 minus. Yes, there we go. They fit together. Okay, so yes, the formula is 1 calcium and 1 oxygen. So we just would type, all right, CaO. This actually is the easiest ionic compound to do. Any ionic compound where the ions have opposite charges, you know that you can just combine 1 and 1 of each. In fact, look, that'll help us in the next problem right here. This Fe is 3 plus, this P is 3 minus, so I know we're just going to be 1 of each, Fe, P, all right? Now, what's the name of this compound here? Well, Fe is iron. Okay. And what is this? Well, P is phosphorus, but the negative ion is phosphide. Okay. Does this need a Roman numeral in the name? Well, let's see. Is iron one of those elements that has many different charges? I'm going to go look at this thing right here. And Fe, Fe, Fe. I don't see iron anywhere on here, which means that iron is one of those elements that has multiple charges. Okay, so yeah, I do need a Roman numeral here. This iron has a +3, so I'm going to give this a 3 charge. All right, iron 3 phosphide. All right, cool. All right, on to this next one. All right, now I'm going to do another strategy for these next three. I'm going to use the crisscross method to figure out the formula. Okay, name first. All right, this is Be, which is beryllium. Okay, and Br is bromine. The negative ion, though, is bromide. So beryllium bromide. Does it need a Roman numeral? Well, let's take a look. Do we see? Here's beryllium. Beryllium is always a 2+ ion. So no, it does not need a Roman numeral. No Roman numeral needed. Okay? Now, the formula for beryllium bromide. What is the ionic compound formula unit? Well, we can do the crisscross method. Now, here's how the crisscross method works. All right? Be 2+, Br 1-. Now, the way the crisscross method works is this just a little mathematical trick where whatever the charge is of one ion, that's how many you have of the other guy. All right, this is a 1- charge, which means I'm going to have one of this guy over here, which means the formula is going to be Be1, all right, not -1, just Be1, Br2. All right, so BeBr2 is the formula for beryllium bromide. Okay, this was what number was this from the homework? Number 9. All right, this is number 9 right here. Cool, 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 cool. All right, yeah, so BeBr2. Okay, let me write that in. Here I go. All right, BeBr2. And I'm going to make sure I highlight this too. Format, text, subscript. All right, cool. Great, great, great. On to the next one, okay? Cu2+ and C4-. All right, let's do the name first, as always. Well, Cu is copper. And C4- is carbide. Okay, now, reminder, do I need a Roman numeral? Is copper here? Is copper here? Cu. I don't see copper here, which means that it is one of those elements that has multiple charges, so we need Roman numerals. All right, this is copper with a 2+ charge, so I'm going to call this copper 2 carbide. Okay, now it's time for the formula. Okay, let me go back and let me do some crisscrossing again. Okay, so let's hear number 10. So copper is 2+ in this case. Carbide is 4-. So we're going to crisscross. All right, this 2, that's how many carbons we're going to have. This 4, that's how many coppers we are going to have. So Cu4, C2. Now this is almost right. Almost. You got to remember that you need to reduce these numbers down here. Okay, if they can be divided by the same thing, then you do so. These can both be divided by 2. So we get Cu2C. Remember, we are looking for the lowest ratio formula here. Cu4C2 is not the lowest ratio. The lowest ratio is Cu2C, copper 2 carbide. Okay, let's just put that in the answer. Here we go. Cu2C. Very good. Format, text, subscript. All right, cool. Let me do one more here. Oh, another carbide, another carbide. Okay, so this one is lithium, Li, and C4- is carbide. Okay, do I need a Roman numeral? Well, let me take a look here. Is lithium on this chart? It is. It's always +1. So it does not need a Roman numeral. Okay, so this is just lithium carbide. Cool. Okay. Now, to crisscross here to get the formula. All right, let's see here. Insert, page break. Okay, here we go. So, lithium carbide. Okay. Again, this lithium is a 1 plus charge, so that's how many carbons we're going to have. Just one. This carbon is a 4 minus charge, so that's the number of lithiums that we are going to have. It's Li, make this bigger, it's Li4C. Okay, that is the formula for lithium carbide, Li4C. And just to be sure that I'm doing this correctly, I'm going to pop in here and take a look at this ionic compound workspace. Okay, so lithium is +1. Carbide is 4 minus. So let's see here. All right, that doesn't work. No. No. Move this up a little bit, get into range. There we go. So yeah, we do need 4 lithiums to cancel out the charge of 1 carbide. So it is Li 1, 2, 3, 4, and then 1 carbon. Okay, cool, guys. So that is your first help video for this homework. Okay, Li4C. Okay, cool, cool, cool. Format, text, subscript. Okay, now I'm going to stop this video and I am going to do another help video for the next set just to keep these things a little bit shorter. All right, there you go, guys.